in December 2017. Her research interests include recommender systems, text mining, social media, social computing, misinformation spread, machine learning, and its application to software engineering processes. She has authored several publications on topics related to recommendations in social media, community detection, feature selection, and software dependency predictions. Please join me in welcoming Dr. Antonella.
Thank you for your presentation, and thank you so much for the invitation. It's a pleasure to be here today. So I'm going to skip the presentation as everything was already mentioned. I'm from Argentina, from a small town called Tandil, near the capital city. So today we'll be talking a little bit about the smart cities, how to transform them on social cities, and what can artificial intelligence do for us. We'll be talking a little bit about some principles that Professor Soha mentioned, like privacy, fairness, and security. So first, what happens with smart cities? In the last few years, we have seen a transformation of cities into what's called smart cities, thanks to also the advancements of technology. Why? Because a future of cities is being planned based on the new technologies to support activities. But this focuses on building cities infrastructure instead of attending citizens' needs to gather and form communities. So what happens with this? We're not considering the social nature of human beings, and we don't analyze how disruptive technologies can be to the sense of community and citizenship. So we need to understand that there's more to smart cities than information processing. Smart cities require more than just technology. We need means to connect citizens and governance structures to ensure that all citizens have the opportunity to benefit from the knowledge-based and working community. And in the same sense, citizens shouldn't just be a form of data collection. They can provide us with more. We need to emphasize deep and meaningful civic engagement or community control to plan together with the citizens. It's not just to convert the city into smart. We need to throw everything we can, every technology we can, every artificial intelligence approach we have. We have to work with the citizens. We need to solve challenges. We need to solve the problems. Technology per technology is useless. So we have been mentioning artificial intelligence. So Professor Soha has also mentioned it. It's not a silver bullet, cannot solve everything, but it can help us to tackle some of the world's most challenging social problems. And which problems should we be tackling? Okay, the United Nations has some sustainable development goals that set different areas in which artificial intelligence could help. In this talk, we will be focusing on a few of them and be showing some examples of how artificial intelligence can actually help to accomplish those goals. First, we have the public and social sector. We have initiatives related to efficiency and effective management of public and social sector entities, such as strong institutions, government transparency, and financial management. For example, what can we do? We can use artificial intelligence to identify tax fraud using alternative data, such as browsing data, retail data, or payments history. Notice that we could be also using government's data, but we have a trade-off between security and privacy. And why this could be important? Well, we could be talking about digital citizenship to foster the exchange between governments and citizens, to foster the participation of citizens, to involve the extension and transformation of participation in societal processes mediated by technologies. For example, just setting up a poll on Twitter or on Facebook or an official platform will help citizens to feel more engaged with the government, feel that they're taking part of the process, of the decision process. Because why would we want to do this? Because formal political processes depend on the effective communication with the public about public decisions with the citizens. We need to support the active citizenship. And what can we do with this? We can study the relationship of the government with the citizens. We can study the characterizations of citizens. We could see which group aims at participating more, which group receives the more information. We can create citizen profiles, and we can estimate the engagement cycle of citizens. We did some study here in Argentina and tried to discover which ways the government was using to connect with the citizens and how the communication should shift so the citizens should be more engaged or more content by the government. Other topic we could be talking about is economic empowerment. The idea is to open access to economic resources like jobs or market information, but also related to agronomy and to farms. Why? We can use artificial intelligence to detect plant damage early through sensors to improve yields for small farms? And can we also use artificial intelligence to determine the body conditions of cows? Why is that important? In the case of cows, the obesity degree affects the feeding management that we have to do with such cows, and can also affect the lactation, which will influence milk production, reproduction, and cow health. So this is a work that was done as part of my research institute, in which they use CNN-based models to estimate the body condition of cows from deep images. The idea was to optimize how the farm was managed, try to reduce the waste, and try to reduce the waste of the food waste, and try to improve how milk was produced. All other area that we have is health and hunger. Try to do some early stage diagnosis, optimize food distribution, or even try to, with artificial intelligence, to try to discover whether some skin abnormalities are cancer or not, or try to detect problems with diabetes using heart rate sensor data, or even sedentary detection. In the last few months, due to the COVID, some approaches have appeared that try to use deep learning to predict whether a person has COVID or not based on X-rays. Here we have some important considerations about privacy, about whether we obtain, how we obtain the data, whether we share the data, and whether we get user consent for that. In this case, they use a combination of different deep learning approaches to try to do the predictions. According to the authors, their particular combination of networks allow to improve traditional architectural results. On the other hand, we could also be talking about mental health. What happens with the COVID and mental health? How can we study mental health through social media? Okay, what we tried to do here was to detect some particular markers that allowed us to infer the mental state of users and try to discover whether there were some spikes or not, like here and here, and whether such spikes were correlated to some events in the real world. For example, we found coincidences between these spikes that could imply the more heavily anxiety area here and here, that were correlated to events related to the extension of lockdown. Remember, here in Argentina, we're still under lockdown in most parts of the country, and some activities here that were also related to economic problems that appeared due to the lockdown. Other problem that we have to face is information validation and verification, also really important in the last few years. We have tons of fake news. We have plenty of examples on Twitter, on Facebook, and the idea is that we have social media. Social media allows to do everything, and we can also rapidly share a lot of fake news. The idea is to the news look credible, but they're easily spread, but they're just lying to us. We need to focus on filtering, on contracting, misleading, and distorting content, including false and polarizing information disseminated through internet and social media. Why? Because it's a threat to access to reliable and trustworthy information, and also to the establishment of reliable social networks. We have seen a lot of work in the last few years about this, about the identification of users, whether a user is a spammer, whether a user is a bot, and we also see some manipulation and consequences on the real life. We have seen mob killings, for example, in India, after a video was shared on WhatsApp. We have seen stock changes, particularly in the United States. There were some actions dropped due to some tweets. We have seen health problems and political manipulation. Particularly on the US elections of 2015, the same as in Argentina. Here we have, for example, some networks where we see other type of fake news, like conspiracies, in this case, the chemtrails, and here anti-vax campaigns. And we can see also the formation of some echo chambers and filter bubbles, which are phenomena that we also don't want on social media. We want to access to all kinds of information, and not just to be restricted to the things that we already like or we already know. That can cause a confirmation bias. Once again, in the last few months, we have seen a rise of fake news related to COVID, which pushed the companies to try to apply some policies and some techniques to try to force users, well, not force, to try users to read the official information and not just sharing whatever they see on their feed. Twitter, for example, applied a policy in which if you want to share a tweet that contains a news article or a link to a news article and you haven't clicked on it, you cannot share it. It shows a message saying, okay, but the title is not enough, you should read all before sharing it. Here we have an example, it's in Spanish, it's from our president, that mistakenly share a fake news regarding which measure we should be taking into account to prevent COVID. Particularly, he said if we drink hot beverages, we will be protecting ourselves from the COVID. It took like 2 days to be debunked, and they never apologized for saying this phrase. And lastly, we have security and justice. Why we want to focus on security and justice? Because we want to predict and prevent crime and other physical dangers, and we can also try to track criminals. And it could be also, more importantly, to mitigate bias in police forces. We have seen a lot of examples in which we have artificial intelligence systems in which there is a racial profile that has more chances of being highlighted as guilty than others. But we can also do other things. For example, we can try to use IoT devices, Internet of Things devices, in combination with artificial intelligence to create solutions for firefighters, to try to determine safe path through burning buildings. There have been modeling about 3D modeling of buildings, and we can try to see whether we can move or not, like a labyrinth. And in the same way, we can design and simulate evacuation plans. In Argentina, particularly, what has been done is tracking of crimes. And we have in Buenos Aires, the capital city, they have designed some maps showing in which districts we have a higher number of crimes and which type of crimes we have. This is the central part of the city in which we have a lot of theft, a lot of car theft, and even property damage. But everything has a limit. We have some critical barriers for every domain that we show that are particularly focused on data and expertise. Why we're saying that we have some limitations regarding data? Well, first, data availability. Why? Most of the data that we would need to provide solutions for this kind of problems is in private hands or in public institutions that might not be willing to share their data. But why wouldn't they want to share this data? For example, on private owners, we have telecommunications and satellite companies, social media platforms. Everyone working with social media knows how hard it is to get real data. Financial institutions like banks, or for example, the National Central Bank. In our case in Argentina, they try to put a tax. Well, they actually put in the tax, and the banks needed confirmation from the central bank to know whether they had to tax their clients, and the central bank denied the access to the data. Why? They never provided an explanation. They just wanted to buy time. At the end, they have some judge that ruled that they had to provide the access. Then we have hospitals and doctors or health providers. It's really sensitive information to be sharing the private medical records without user consent. So we have to be very careful when we are using medical records. And also we have governments, as I was saying, the tax information for private individuals. And why is data difficult to obtain? Okay, not only regulations. Remember, for example, that Europe has a GDPR that makes really difficult to be freely using data or even storage. But we also have bureaucratic inertia and the business value. No company would want to share data that could make a profit for them. And the other aspect that we should be taking into account is expertise. We just not need expertise in building the models, but also on interpreting the results. And we'll be talking a little bit later about interpretation. And even if a model achieves a desired level of accuracy on test data, we need to be prepared of what would happen when we try to new unanticipated failure cases in real life scenarios. It's naive to believe that if we test our tool, there were not going to be new data that's going to tank our efforts. And we need someone to translate it. We need someone to explain why the models output the results. And without the translation, the model couldn't be trusted too much. So we really need someone to have expertise on this. And what can we do? Okay, we've been talking about using artificial intelligence to create new opportunities to improve the life of people around the world on a different variety of challenges. But we should also be aware that artificial intelligence tools can be misused. So we need to establish principles to guide their research. And it's also raising questions about which is the best way to build the solutions. As some movie says, with great power comes great responsibility. And here is the key word, how to be responsible. Well, some companies have started to think about some principles and some guidelines that we should be taking into account to provide some safe, secure, and fair solutions. Particularly, we'll be talking about fairness, interpretability, privacy, and security. When we talk about fairness, we're saying that systems have the potential to be more fairer and more inclusive than ad hoc process or human judgments. But the AI solutions can unintentionally harm the very people they're supposed to help. Think about, for example, some hate speech detection systems that are in place that were trained based on lexical data. And what caused that? They were trying to protect, I remember it was a university in the US, they were trying to protect their Afro-American population, and they started to train based on tweets. And the thing was that the tweets were trained on specific particularities of language that were also used by Afro-American. So everything written by an Afro-American due to those keywords that they were using was flagged as hate speech. And they ended up kind of censoring the same population that we're trying to protect. The thing is that if we have an ad hoc system, the risk of being unfair is high, but maybe the reach of the unfairness is not so big. On the contrary, when we deploy an artificial intelligence solution, when we deploy this kind, for example, hate speech detection systems, the unfairness of the system had a wide-scale impact because it reached to more people. Models can be also used to identify some of the conscious and unconscious human biases and barriers for inclusion. We need to make sure that artificial intelligence solutions are not trying to perpetuate or aggravate existing prejudices and social inequalities that could lead to affecting the already vulnerable populations that we are trying to protect. It's critical to work towards systems that are fair and inclusive for all. But this is easier said than done. Why? Because models learn from existing data collected from the real world. So our models would be as good as the data that we train them are. So if we have datasets that have some unconscious bias, for example, culture, gender, or religion, we will be perpetuating such biases. For example, there are some systems that are in place for trying to select some candidates for a work position, and they might have a bias against gender, or in translations, they might assume pronouns. For example, English is gender neutral, but Spanish not. So sometimes when we are translating a word, we may be unconsciously translating to the female part, for example, a nurse or a babysitter. Also, it's a challenge to ensure that the system will be fair across every possible situation. We can have our system in place, we can be working great, but we train it only with adults, with US adults. And this system has a particularity that depends on the language that we use on the training users. What happens if we try to use the system with teenagers that remove the language and evolve it and use different terms that adults? The system is not going to work. And it's not a problem that we introduce a bias in the system. It's just that the context on which I'm using it is different. And maybe we should prepare our system to deal with such different contexts. And also, the identifying appropriate fairness criteria should take into account user experience, cultural, social, historical, political, and ethical considerations. Not everyone is the same. Not every place in the world works in the same place. And here we'll also be talking about bias in tagging. As I said previously, models are as good as the data we use to train them. What happens if the taggers that are providing with data have some bias or some different demographic characteristics that makes them susceptible to, for example, to particular attacks on hate speech that other populations aren't? How can we be sure that the taggings are correct or that the taggings are going to work in a particular group of people that we're going to test it? And what can we do for fairness? Okay. We have to design models using concrete goals for fairness and inclusion, how the technology and its development over time will impact different use cases. Do we have the possibility of getting other users, other kind of users, other users from other country, other cultural bias, other background? Use representative data sets to train and test the model. Assess fairness in your data sets. Try to identify the representation and corresponding limitations. Try to determine if it's discriminatory in any way. Understand various perspectives of data. Try to train the system with data belonging to different subgroups. Try to test with different subgroups. and then check the system for unfair biases. While designing metrics to train and evaluate the system, try to also include metrics to examine performance across different subgroups. If we have different demographic groups, try to test the system with each of them. Try to train the system with each of them and see what happens if you do some cross-testing. Then we have interpretability. It's crucial to be able to question, understand, and trust artificial intelligence systems. Why? Because it's going to reflect the domain knowledge and the societal values, and also provides better means for designing, developing, and even debugging the system we are developing. We need to ensure that artificial intelligence systems are working as intended. And also, it provides some means to compare to traditional software. Why? Because we have kind of a trade-off. We have the new models, the new complex models, the deep learning models, for example, that have millions of parameters and mathematical operations. And it's harder to pinpoint what leads to a faulty decision. Sometimes the deep learning models are regarded as black boxes that cannot be explained. On the contrary, we have traditional software that essentially is a series of if-then values. And while it can be some cumbersome, we can actually have a human to track the path taken through the code, understand it, given results. But we have another problem. When we refer to complex systems, we can say, okay, anyway, it's hard. We have to follow a lot of mathematical operations, but in the end, the values can be traced to the training data or to the model. On the other hand, it's possible that our human managed system will have some magic numbers, magic thresholds, or no forgotten rules, or even personal intuition that can affect explanation. Because if that person left the company or left the area or forgot about the algorithm, we're not gonna get any explanation. And what can we do to improve the interpretability of our results? First, we need to plan how we're gonna deliver interpretability. Before, during, after the designing of training a model, do we have a system in place that we need to interpret, or are we building from scratch? What degree of interpretability is really needed? Because we can go both ways. We can actually be given too much information that is not going to be useful for the user, and it's going to confuse it more. Or we can be given too little information that leaves a lot to the user to think about and to interpret on their mind, and maybe they can get to the wrong conclusions and stop using our system due to some prejudice. Then we need to design the model to be interpretable if we can do it. We have to make sure to use the smallest set of inputs necessary for the performance, to be clear on what factors are affecting the performance, on which factors are defining the configuration for our model. And try also to use the simplest model that meets the performance goal. Try to learn causal relationships instead of correlations when possible. And finally, we need to choose to reflect the end goal and end task. When we try to decide on which metrics to evaluate the system, we need to think about the particular benefits and risks of the specific context. For example, we always have heard the discussion between precision or recall. We need to analyze model sensitivity to different inputs and for different subsets of our examples. And what's also important is to communicate explanations to model users. We could have the best explanations for our team, but what happens if the user can't understand it? What happens if the user gets an interpretation that is not easily readable or cannot comprehend? We need to make sure that there are also careful consideration of philosophical, psychological, and computer sciences, including human-computer interaction, legal and ethical consideration about what's a good explanation in the different contexts our tool is going to be used. And identify if they're going to be appropriate. I mean, are they causing more confusion? Our users can't really understand what we're trying to say. And also prioritize explanations that suggest clear actions a user can take to correct inaccurate predictions going forward. Don't imply that explanations mean causation unless they do. Be careful with what you say to the client or to the user. Try not to raise expectations, but also try not to provide too little information. And be mindful of the limitations. Explain also them. Try to make sure the user understands what the limitations of the system are. Then we reach to privacy. We already talked about this. We have data that can be sensitive, and we don't want that kind of data to go public. For example, medical records, X-rays that we use for training our COVID system. Even though we have a lot of benefits of using sensitive data to train our models, We have to be sure about the potential privacy implications of using it. And we also have detected some bias regarding this information. Sometimes we have incomplete information when we are using our data. Our medical records, for example, are totally anonymized, and we have even indications for gender. But in some cases, for medical cases, it's important to have that kind of information. So be aware of what do you really need and what can you get. And now we're not only talking about legal and regulatory requirements, as I mentioned with the GDPR law in Europe, but we're also talking about social norms and typical individual expectations. And our system should be careful and try to understand what safeguards do we need to put in place to ensure the privacy of individuals that, considering the machine learning models, may remember or reveal aspects of the data that have been exposed to. And also, what steps are needed to ensure users have adequate transparency and control of their data? Are we allowing users that provide us with data to remove it from the system if they ask? Are we actually accomplishing that? And what can we do for improving privacy? Okay, there's no correct or single approach that could work on every scenario. So we need to balance privacy and utility. And we need some principles. First, to collect and handle data responsibly. We need to identify whether our machine learning artificial intelligence model can be trained without using sensitive data. And we should take into account the anonymization and aggregation of data in cases we actually can use it. For example, if we don't need the raw information of a user, try to collect a summary of information on the statistics of the data and just save that to avoid having much more data than we actually need from the user. And also, we need to consider the privacy impact of how the models were constructed and may be accessed. For example, is our model unintentionally memorizing or exposing sensitive data? What happens with the different inputs we get to the system? Is it possible to derive an output? Is it possible that our user can trick the system into revealing data? And also, train machine learning models using techniques that establish some guarantees for privacy, anonymization, mathematical anonymization, aggregation, or whatever suits our needs. And finally, we reach security. What security tries to see is that our system is behaving as intended, regardless of how attackers are trying to interfere. It's essential to consider and address the security risk of our artificial intelligence system before it's deployed, and it's widely relied upon safety-critical applications. We have a lot of challenges to tackle with this security because it's hard to predict every scenario ahead of time, especially as new ways to interfere with the system or to attack them are appearing constantly. It's hard to build systems that provide both restrictions for security as well as the necessary flexibility to generate creative solutions, and we need to be sure that our system has at least some measures to the most traditional attacks. And what can we do for this? We try to identify potential threats to the system, whether anyone would have an incentive to make the system misbehave. What is the cost of the system misbehaving? What is the cost of someone interfering with the data or feeding it spurious data? Identify the consequences. What's the consequence of a mistake? For example, we have a false negative. Is it worrisome? Do we need to worry about that? Or we can leave it and just flag it? And build a rigorous threat model to understand all possible, at least the most higher number of possibilities of attack vectors. So, what do we need to keep from here? Artificial intelligence is going to help us a lot. Also, as Professor Soha was mentioning about the solutions, about biology, about challenges, societal challenges, but as well as providing new opportunities, it also can be misused. So we need to have some principles guiding us when we are developing the tools. We have fairness, interpretability, privacy, and security. Fairness, try to avoid perpetuating some unfair situations. Try to make systems work with everyone and in every place. Try to interpret results. Why users were given the output? What do they need to understand about our system? Be conscious about privacy. Do we ask users for consent? Do we have access to data? Can we, instead of storing sensitive data, work with anonymization data or aggregates or statistics? And make sure that system is protected. Try to avoid being attacked. Try to avoid having the system misbehaving. Try to protect the data, try to protect your users. So thank you so much for the invitation. I'll be happy to take any questions you might get. Here you have my website.